me just double check. I don't see any that are z-scores on there, but if you wanted to do number 19, you would just have to plug it into the formula. This is going to come up again in chapter 7, and 8, and 9, and 10. So for 19, you would use z equals, and this is a population, right? Because it's everybody in the race, so it's going to be x minus mu over sigma. If you use the other one, it doesn't matter, because as long as you have your mean and your standard deviation right, you're going to plug them in the same places. It's just a matter of rotation. So if we're looking at Mike's, let's see. He finished in 184.43 minutes. So he's got 184.43. So this is Mike. Here's the mean or the average. The mean was 185.65. And then the standard deviation for Mike, which was 0.389. Put that into your calculator. You should get negative 3.14. Then we'll do the same thing for the next person, who is Jane. So her z-score is going to be Jane minus the mean. So Jane had 112.07. Over standard deviation 0.125. That's our standard deviation, and that one should give you back a negative 1.84. Okay, so this is their z-scores, and you're looking to see which one is more convincing. This is going to be different than when we compared the two heights, because we're not looking to see who's taller. We're looking to see who finished faster. So it's kind of like golf, where a low score is good. This one you want your time to be small as well. So we're looking at this one over here. He's more than 3 standard deviations below the mean, so he finished in a much faster time compared to everybody else in his course. So with these ones, because they are 2 different races, even if it was the same track, it's going to be different because they might have different driving conditions, the weather is different, you know, that type of thing. So even if it's the same course, since they're 2 different races, you can't just look at their times, you have to look at how they compare to everybody else. So compared to everybody else, this guy finished much, much faster. He's more than 3 standard deviations away from the mean, which we saw previously. Only 0.3% of data values, oh my goodness, fall outside of 3 standard deviations. 99.7 is going to be within 3. So he did really, really well with having a z-score that small. She still won, but her z-score isn't nearly as impressive as his was. So that's why Mike had a more convincing victory. His is more impressive because his z-score is so